I'm your host, Dr. D. Welcome to Math in the House. Today, we're doing Math Analysis, Chapter 8, Section 3, De Morgan's Theorem. I'm your host, Dr. D. Okay, now this section, we're going to be dealing with the work of a French dude by the name of De Morgan. That's a pretty good pronunciation, I'd say. But yeah, it's kind of difficult for an English-speaking person to speak French. You could injure your throat if you're not careful. Okay, so what De Morgan's theorem says is that if you have a complex number that's r cis theta, then if you want to take that to a particular power, then what you do is you take the radius to the power and then you multiply the angle by that power. Now, if you look at, here's a complex number, -1 plus I. We want to take it to the 8th. Now, what a lot of people think when we're multiplying complex numbers is changing the rectangular to polar and then doing the product and then changing it back to rectangular, that's a major hassle. Well, taking it to a power, you want to FOIL this thing 8 times in a row? I don't think so. So we want to change it to polar first and then use De Morgan's theorem. So change -1 plus I into polar form. Well, we're going left 1, up 1. So there's -1 plus I. Well, that means the angle is the pi over 4 angle in the second quadrant, which is 3 pi over 4. And the magnitude is 1 squared plus 1 squared is 2, takes square root of 2. So that's it. It's square root of 2 cis 3 pi over 4. All right, now it gets easy. This becomes r to the n, which means square root of 2 to the 8th, cis n theta, 8 times 3 pi over 4. Okay, so that equals square root of 2 to the 8th is 2 to the 4th, which is 16. And 8 times 3 pi over 4 is going to be 2 times 3 pi, which is 6 pi. So this just equals 16 cis 6 pi. Well, where is 6 pi? It's just 3 times around back to 0 again. So it really becomes the same thing as 16 cis 0. Now, that means 16 straight to the right. That's just plain 16. All real, all natural, everything's happy. Okay, so notice this really is simpler when you change your rectangular to polar and you know it's left and up, so you know the angle, you know the magnitude. Now we take the magnitude to the power, cis, the power times the angle, and ends up being 16. Okay. Let's try another one. We have this huge, nasty equation, And we're told that z might equal -3 minus 3i. And so what we want to do is we want to plug z into that and see if it's actually true. Now here we have a rectangular form to the 4th power. That's ugly. We don't want to do that. What should we do? Well, let's change z to polar form. Okay, so -3 minus 3i means we're going left and down. So -3 minus 3i. So you know the hypotenuse is 3 square root of 2. And you know the angle is pi over 4 past pi, which is 5 pi over 4. So z equals 3 square root of 2 cis 5 pi over 4. Now we can plug that in here. So 3 square root of 2 cis 5 pi over 4 to the 4th plus 6 times 3 square root of 2 cis 5 pi over 4 cubed plus 19 times 3 square root of 2 cis 5 pi over 4 squared plus 6 times 3 square root of 2 cis 5 pi over 4 plus 18 should equal 0. Let's see if it does. So when I'm taking this thing to the 4th, it's just 3 square root of 2 to the 4th. So 3 to the 4th is 81. Square root of 2 to the 4th is the same as 2 to the 2nd. So we have 81 times 4, which is 324, cis. Now, multiply the angle by 4, and you have 5 pi. Okay, now we've got plus 6. Now, we're taking the magnitude to the power of 3. So 3 square root of 2 cubed, well, 3 cubed is 27, and square root of 2 cubed is, we'll just go 27 times 2 to the 3 halves, cis 5 pi over 4 times 3 is 15 pi over 4. Plus 19 times, now we square this, so 3 squared is 9, square root of 2 squared is 2, 9 times 2 is 18, cis 5 pi over 4 times 2, which is 5 pi over 2. Plus, now we're just going to distribute this. So 6 times 3 square root of 2 is 18 square root of 2, cis 5 pi over 4, plus 18 should equal 0. All right, now let's clean things up a bit. Where is 5 pi? Well, that's going to be twice around the circle, which makes 4 pi, and then one more half circle, which makes pi. So it's 324 cis pi. Well, 324 cis pi is just negative 324, because remember, pi is directly to the left. Now, cis 15 pi over 4. So let's just distribute this. So we've got 6 times 27, which is 162. Let's see. Yeah, 162 times 2 to the 3 halves cis. Now let's change 15 pi over 4 to, if we go pi, take 2 pi off that. So we're going to take 8 pi over 4 off that, and that's going to be 7 pi over 4. Now, plus 19 times 18 cis 5 pi over 2. So that's 342 cis 5 pi over 2. Now where is 5 pi over 2? Well, it's the same as pi over 2, which is straight up. So that just becomes 342i. Okay, now, 18 square root of 2 cis 5 pi over 4 is going to be, yeah, that's as simple as we can do that. So we'll just keep that. Plus 18 equals 0. Okay, now, to make this simpler to see, instead of 2 to the 3 halves, let's just make it the square root of 2 cubed. Okay, now, next thing we want to look at is cosine of 7 pi over 4 is square root of 2 over 2. But instead of saying square root of 2 over 2, let's just say 1 over the square root of 2. So we've got 162 times square root of 2 cubed times, now, cosine 7 pi over 4 is 1 over square root of 2. And I sine 7 pi over 4 is going to be minus 1 over the square root of 2i. Because remember, 7 pi over 4 is right and down, so cosine's positive, sine's negative. Now we have 342i. And now we have 18 square root of 2. Now cosine of 5 pi over 4, that's left and down, so cosine would be negative square root of 2 over 2, and once again we're going to make this just negative 1 over square root of 2 instead of square root of 2 over 2, and then minus square root of 2 over 2i. All right, now when I multiply this over, I have negative 324 plus. Now 162 times square root of 2 cubed times 1 over square root of 2, that's square root of 2 squared. So that's just 2. So 162 times 2 is 324. Now 162 square root of 2 cubed times negative 1 over square root of 2i. So a square root of 2 cancels, and I'm left with minus 324i. Okay, now I have plus 342i. Now, 18 square root of 2 times negative 1 over square root of 2, square root of 2's cancel, and that just becomes minus 18. And then becomes minus 18i, and there we have our plus 18 equals 0. All right, so now I've got negative 324 plus 324. That's 0. Now I have negative 324i minus an 18i, and that becomes negative 342i. So negative 342i and positive 342i cancels, and then I have negative 18 plus 18 is 0, and that's it. It all cancels. 0 equals 0. Okay, that's quite enough. Okay, so if you're willing to go through the steps patiently, and if you know your cosine and sines of your special right triangles, piece of cake. All right. Now we're going to crank up the juice just a bit. Oh yeah! Okay, so finding the nth roots of complex numbers. So we're not taking it to a power, but we're taking it to a fractional power. And this is going to add a little excitement to our lives. Here's an example. X cubed minus 1 equals 0. We're solving for x. Well, so we add 1 to both sides, so x cubed equals 1. We take the cube root of both sides. So you think x equals 1 and that's it. But that's where you would be wrong. So here's what we do. We say it's 1 to the 1/3 power. Now I'm going to take my 1 and I'm going to change it to a polar form. So 1 real means 1 cis 0. That's 1 straight to the right, to the 1/3 power. So what I have then is 1 to the 1/3 cis 0 to the 1/3. But here's the way we do it. We go 1 to the 1/3 cis, not just 0 over 3, but 0 plus 2 pi n over 3, where n is 0, then 1, then 2, then 3. Now, watch what happens. When n is 0, then we're just going 0 plus 0 over 3. So that means I have 1 cis 0, and that equals 1. And that's exactly what we thought it was. Well, here's the ones that we didn't know about. When n is 1, then I have 0 plus 2 pi times 1, which is 2 pi, over 3. So 1 cis 2 pi over 3. Well, cosine 2 pi over 3, remember, 2 pi over 3 is that 30, 60, 90 triangle in the second quadrant. So that means the adjacent's -1, the opposite is square root of 3. So cosine 2 pi over 3 is -1/2, and sine pi over 3 is positive square root of 3 over 2. So we have -1/2 plus I square root of 3 over 2. Now the interesting thing is if we take this value and we cube it, we'll get 1. Now, when n is 2, then we have 1 cis 0 plus 4 pi over 3, which is 1 cis 4 pi over 3. So we do the same thing. Where's 4 pi over 3? It's down here. Nice. It's down here. So there's my -1, there's my negative square root of 3, and there's my 2. So cosine is -1/2, and sine is negative square root of 3 over 2. So x equals -1/2 minus I square root of 3 over 2. Once again, we cube this puppy, and we get 1. Now, if we go one more to n equals 3, then notice what I have. 0 plus 2 pi times 3, which is 6 pi over 3, which is 2 pi. Well, 1 cis 6 pi over 3 is the same thing as 1 cis 0, which is 1, which is the same as the n equals 0. So anytime we're taking the cube root, you're going to have 3 unique solutions, and then the next one will be a repeat of the first one. If we have the fourth root, there will be 4 unique solutions, and then the fifth one will be a repeat of the first one. And the same thing, the fifth root means we're going to have 5 unique solutions, and the sixth one becomes a repeat. All right, so let's crank up the juice just a bit. Okay. So now we have x to the fourth minus 1 plus I equals 0, and we want to solve for x. Okay, so that means x to the fourth equals 1 plus I. Same idea, we just add 1 plus I over to the other side, and now we take the fourth root of 1 plus I. Now, we don't want just 1 plus I to the 1/4, we want it in polar form to the 1/4. Now 1 plus I is 1 right, 1 up. So you know the angle is pi over 4, and you know the magnitude is the square root of 2. So 1 plus I becomes square root of 2 cis pi over 4 to the 1/4 power. Now, what do? Well, first we take the square root of 2 to the 1/4 power, which is 2 to the 1/8. Now that's our magnitude on every single one of these. Notice 2 to the 1/8, 2 to the 1/8, 2 to the 1/8, 2 to the 1/8. Well, actually, it should be. Not 1/4, but 1/8. Okay, so now what's our angle going to be? Well, it's going to be the angle we start with plus 2 pi n. So pi over 4 plus 2 pi times 0, pi over 4 plus 2 pi times 1, pi over 4 plus 2 pi times 2, pi over 4 plus 2 pi times 3. Now, it's the 1/4 power though, so everything gets divided by 4 because it's the 1/4 power. Okay, so we have our n equals 0, n equals 1, n equals 2, n equals 3, so let's just do this thing. So pi over 4 plus 0 over 4 is pi over 16. Pi over 4 plus 2 pi is pi over 4 plus 8 pi over 4, which is 9 pi over 4, which is 9 pi over 16. And then pi over 4 plus 4 pi is pi over 4 plus 16 pi over 4, which is 17 pi over 4, which is 17 pi over 16. And then pi over 4 plus 6 pi is pi over 4 plus 24 pi over 4, which is 25 pi over 4 is 25 pi over 16. Now let's say we go one more. We go to n equals 4. Well, what's going to happen? It's going to be pi over 4 plus 8 pi, which is pi over 4 plus 32 pi over 4, which is 33 pi over 4, which is 33 pi over 16. Now, if we have 33 pi over 16, we're going to subtract 2 pi from that. So that just becomes pi over 16. So notice it's the same thing as our first term. So it's the 4th power, so we have 4 unique solutions, and the 5th one would repeat the n equals 0 case. Okay. Now, all we need to do is figure out cosine and sine of each one of these angles, and since they're not special triangles, it's a calculator issue. So all I do is I go 2 to the 1/8 power. Now on the calculator, I'm going to go 2 enter, 8 reciprocate y to the x. That's it. 2 to the 1/8 power. 2 enter, 8 reciprocate, and that's that 1 over x button, y to the x. Then I go pi over 16 cosine times. I get 1.07. Then I go pi over 16, take the sine of it, and multiply by 2 to the 1/8, and I get 0.21i. So there's my first solution. Then I do the same thing here. Cosine of 9 pi over 16 plus I sine 9 pi over 16 multiplied by 2 to the 1/8, and I get negative 0.21 plus 1.07i. Then I do the same thing here, cosine plus I sine, cosine plus I sine. Now, look what that gives me. When I graph these 4 points on our complex plane, then I get at n equals, let's see, 1, yeah, I have these wrong. This is the 0, 1, 2, and 3. So the n equals 0 is right 1.07 up 0.21. The n equals 1 is left 0.21 up 1.07. N equals 2 is left 1.07 down 0.21. And n equals 3 is right 0.21 down 1.07. Now notice what happens here. We have a square with the center at the origin. Now that will always happen this way. Whenever you do your pieces, it's always going to be a regular polygon. So if it's to the 1/5 power, you're going to have a regular pentagon with the center at the origin. If you're doing the 3, it's going to be an equilateral triangle with the center at the origin. If you're doing 6, it's going to be a regular hexagon with the center at the origin. So that way you can check to make sure you did it right. So that's it. Have fun with these.